И так, я хотел бы, чтобы Фред подтвердил, что он готов.
Yes, good morning. Nice to be here. And I confirm I can see you and hear you, and hopefully you can do the same with me.
Alexei.
Okay, I believe one of your colleagues will put up the slides. If not, I can do it myself, but whatever you prefer. Okay, perhaps if we could advance to the next slide already, please. Yes, so good morning, and first of all, thank you to our ITU colleagues and colleagues in St. Petersburg for the opportunity to be here today. My name is Fred Werner. I'm head of strategic engagement for the Standardization Bureau, and I'm also one of the organizers of AI for Good, along with my colleague Reinhard Scholl and Thomas, who will be joining us for the presentation as well. So basically today I'd like to provide an overview of AI for Good, our AI activities in ITU, and some of the different touch points that you may want to get involved with. Next slide, please. And we can go straight to the next slide as well. Thank you. Yes, so AI for Good was built on the premise that we have less than 10 years to achieve the United Nations Sustainable Development Goals, and AI has great promise to advance many of those goals and targets. Next slide, please. So in a recent mapping that was published in Nature a couple of years ago, they did a mapping of how AI can positively impact the SDGs and how AI can also inhibit some of the SDG targets. And what we saw was that over 130 of the targets can be positively impacted by AI. So what are we looking at here? So for example, the domain of healthcare holds a lot of potential. And some use cases and examples would involve, for example, using your mobile phone, the camera on your mobile phone to detect skin cancer, for example, or to detect diabetes through photographing your eyeball, or even detecting tuberculosis using the microphone in your mobile phone. And we've seen countless applications of AI in the health space, and also providing a lot of applications for persons of disabilities to help them navigate their environments, to help them see, hear, move. Lots of use cases there. Also, for example, in the field of education, we've seen how AI can be used to create customized learning programs in settings where the student-to-teacher ratio is not manageable. And also another example, for example, a language disappears every 14 years, every 14 days rather, a language disappears. And AI can be used to preserve languages, to help translate content from lost languages, and also to help preserve cultural integrity. Other applications include, for example, using computer vision to identify plant disease in low resource settings, or using, for example, satellite imagery to map deforestation and poverty. And also we've seen countless applications when it comes to autonomous driving and trying to increase safety, increase access to mobility, and also in the context of smart cities. But there's no shortage of positive AI for use cases, and we come across them every day through AI for Good, going on for 5 years now. But of course, we must be vigilant, because on the flip side, you also have AI can inhibit some of the SDG targets. So what are some of those? So of course, top of mind is job loss due to automation. So the ILO predicts that hundreds of millions of jobs could potentially be lost to AI. But at the same time, there are predictions that hundreds of millions of new jobs could be created coming out of new value created by AI. But of course, the transition won't be smooth. It will be bumpy. It won't happen overnight. And how do you manage that transition to automation? Another topic that's top of mind, of course, is bias. Now, machine learning, you probably encounter it every day, whether it's through your news feed, your recommendations on Netflix, what you might buy on Amazon. But more importantly than that, AI is being used more and more in different applications in decision making. So, for example, if you might get hired, or if you might get fired, or if you might get that student loan or that mortgage, or if you might even get paroled from prison, or who you might even end up dating. All of these applications use machine learning, and they run on data sets. And we must be mindful that these data sets are as unbiased as possible, because we've seen a lot of use cases where different segments of society might be unfairly targeted or prejudiced against just because of the nature of the data set. So that's something that's very top of mind in our community. Likewise, if you look at ethics, and of course you have the classic example of the trolley problem. So if you had an autonomous car driving down a bridge, and all of a sudden a child crosses the bridge, does it swerve and avoid killing the child but killing the passengers, or does it kill the child? That's not a new problem. That goes back many decades ago. But of course, that goes much further now as we're seeing more and more automation on our roads. We've created a new thing called the Molly problem, which you could say is the evolution of the trolley problem, where you have a new scenario where if there is an accident involving an autonomous vehicle, but there's no one there to witness it, how is that reported? What kind of data is gathered? What kind of decision making was used in the process? What kind of policy and regulation and frameworks exist to actually handle that accident in a way that inspires trust and confidence in AI solutions on our road? Another thing, of course, is data and privacy. That's also very much top of mind. And, you know, the old saying that data is the fuel of AI, but how can you actually use data in a way that's still useful for AI, but also respects the privacy of the data itself? And a lot of discussions are taking place on how to handle data in a way that's useful, but also respects privacy. Safety and security, obviously top of mind. You have the old saying that anything that can be hacked will be hacked. And sometimes it's as simple as putting a few black stickers on a stop sign to confuse the computer vision of an autonomous vehicle. That's a very simplistic example, but you can imagine where it can go from there. And of course, AI can be used as a threat, but it's also one of the high potential tools for mitigating future cyber threats and safety concerns. So you have both sides of the coin there. And maybe last but not least, will AI increase the digital divide or help to close the digital divide? So you could say perhaps that developing countries have the most to potentially gain from AI, but they also potentially have the most to lose from AI if that transition is not managed well. So of course, for a developing country to benefit from AI, you need data. In order to have data, you need mass digitization. For mass digitization, you need connectivity, and a lot of the basic building blocks need to be in place. So these are all things that are very much top of mind in the AI for Good community. But having said that, there are still far more positive use cases than negative use cases. And what we've seen is that it's very important to understand the context. So just because you have an interesting application that was maybe developed in Silicon Valley or in Shenzhen, does that application work equally well on people of different skin colors, of people of different ages, of people of different genders? Does it work in low resource settings? And these are things that don't naturally occur to maybe developers and startups and businesses as they're keeping up with a rapid pace of innovation. But these are things that are very much top of mind of the AI for Good community. So what we try and do is basically connect what we call AI innovators with problem owners who have a very good understanding of the problems of the ground and the context, and help them come together. And simply put, the goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and help to scale those solutions for global impact. Next slide, please. And of course, this is something that everyone should consider and will affect our future. And one of the goals of the summit is to bring as many different voices to the table as possible. Next slide, please. So of course, the AI for Good is organized by ITU and with 38 UN organizations, and co-convened by Switzerland. Next slide, please. And as I said before, yes, the goal is very specifically identify practical applications, things that exist today, and scale those solutions for global impact. And I guess you could say there's also a sense of urgency in that we have less than 10 years to identify these solutions. So solutions that you identify today might need 2 or 3 years to develop. They might need another 2 or 3 years to roll out and deploy. And then you just have about 2 or 3 years less to see any kind of maybe marketable impact or moving the needle on the SDG targets. So there is a sense of urgency among the community that we have to focus on the now, things that exist now, be practical, and work on those things as we speak. Next slide, please. So how do we do this? Well, first of all, we can't do this alone. And the AI experts themselves would say that AI is too important to leave to the experts alone. So we aim to bring as many people to the table as possible. And of course, behind that is the 38 UN sister organizations that are partners of the AI for Good Summit. So these organizations, they contribute, either they help to co-curate sessions, they come as attendees, as speakers, as participants. Sometimes they participate in our focus groups or even help to create focus groups. And we'll go into that a bit later. But I think you can see here that virtually the entire UN system is a partner of the AI for Good platform, if you will, which is quite remarkable. Next slide, please. And also the summit aims to bring together, it's a multi-stakeholder platform, it's interdisciplinary and intergenerational. And what we mean by that is we bring together, of course, the UN agencies, bring together top industry executives and experts, top AI academic experts and top universities, international organizations, civil society, NGOs, member states, government officials, and also the creatives. So if you're looking at artists or poets or athletes, young people, we really do aim to bring as many people to the table as possible. Next slide, please. So one thing I'd like to highlight is our transformation from a 5-day physical event to what we call an all-year online platform. So of course, responding to COVID in March 2020, we had to figure out, what are we going to do? Are we going to delay the event, or are we going to reinvent it? And we decided very quickly, probably a week after lockdown, to just go ahead with our digital programming. And what we found is that this allowed us to scale our mission and reach more people than ever before, be more inclusive, be more diverse. And in doing so, we were able to grow our audience from around 2,000 people that used to come to Geneva for 5 days to reaching 150,000 people online. We more than doubled the number of developing countries participating. The total number of countries went from about 100 to 170, and the gender balance increased by about 10%, from about 35% to 45%. So apart from meeting face-to-face, on virtually every touch point, or KPI, if you will, the summit has really scaled and really helped to achieve our mission in a way that wasn't possible before, and launch more opportunities for collaborations, for partnerships, for knowledge sharing, for knowledge exchange, and connectivity. Next slide, please. And sometimes we've heard in the past few months that they've compared AI for Good to Netflix, or a Netflix for Good, if you will. And this is just a snapshot of a typical week in our program. But since we've gone digital, we're running hundreds of sessions a year, anywhere between 3 and 10 sessions a week on a wide range of topics. Next slide, please. And you could say that now that AI for Good has turned into an online digital platform, and it's basically organized around 3 streams. So we have what we call the Learn stream, and there we have world famous keynotes. We have webinars where you have panels with a debate, discourse, discussion of bringing together different profiles and viewpoints. You have the discovery track where we have expert level talks on different themes. We have perspectives, which are interviews and demos, and on the go, which is straight to social media. And also we have the build track. And one of our claims to fame is that we are action-oriented and we're more than a talk shop. And this build section is really where the action takes place, if you will. So of course you have the AI, the ITU focus groups, our pre-standardization efforts. And I like to think of the activities in these focus groups as the building blocks of AI for good, and also trying to get rid of some very important bottlenecks that are preventing the benefits of AI from being distributed equally and internationally. So if you look at our different focus groups, and regardless of what topic they're working on, or what let's say, vertical they're working on, a lot of things that they're working on are actually blocking points that need to be solved. So how do you handle data? How do you share data? How do you exchange data, label data in a way that's workable and respects privacy, but is still very useful for AI and algorithms to work? They're looking at ethics, for example, in the context of autonomous driving and healthcare. They're looking at biased data sets. They're looking at what standards do exist, what standards don't exist and might need to be developed through a kind of gap analysis. They're experimenting with sandboxes. They're working on measurement and benchmarking. Benchmarking being very important because up until now, that you really don't have any kind of benchmarking frameworks that allow a policymaker or a member state or a municipality to actually reasonably look at, does this algorithm perform better than that algorithm, and will it perform equally well on different segments of society, and so forth. And of course, creating a community of best practice that will inform future standards. And that's, I like to think that even though it might not be the most obvious thing, these are the things that need to be solved if the benefits of AI are going to be realized. Another thing we have is what we call the innovation factory, and that's where it's basically identifying startups that, these are existing businesses that have AI solutions that can directly impact the SDGs. So it's a kind of live pitching competition. And of course, through that, we have other activities like the breakthrough tracks, where we try and build together teams to solve global challenges. We're working on some different AI readiness landscapes, looking at the lay of land across different regions. And also we have different AI challenges, which my colleagues will explain in more detail later. And of course, last but not least, is the connection factor. So of course, we've been connecting online for well over a year now, but we're also launching an AI-powered matchmaking community called the Neural Network, where people will actually create profiles to digest the AI for good content, and the matchmaking will match people to people, people to content, and people to needs or activities, if you will. And then perhaps an eventual return to to a physical event, maybe next year sometime. So with this, I would like to pass it on to my colleague, Reinhard Scholl, Deputy Director of the Standardization Bureau and also organizer of AI for Good, who's going to go more into detail in our AI activities in ITU, how it relates to standards, our focus groups, our challenges. So Reinhard, if you want to turn on your camera, I'll pass forward on to you.
Thank you, Fred. So this is Reinhard Scholl from the ITU. Perhaps before I start with my part, maybe we can take questions regarding the first part. So we would like to invite you to participate on our making good use of our AI for Good platform. And for example, in January of this year, we ran an innovation factory where we featured Russian startups. So that's one example of how we engage your community. My colleague Thomas will also talk about how Russia, especially the University of St. Petersburg, engaged in our machine learning for 5G challenge. We can also do content in Russian. You know, we have had episodes in Chinese, in Japanese, in Portuguese. So, you know, we are also happy to tailor content to the Russian-speaking community. So, are there perhaps any questions before on AI for Good before I move on with my part?
I see one question in the chat, which says, I wanted to check where do we start on pitching for real demos? The solution is in pilot for 2 telcos. I mean, the quick answer to that, I would suggest that you apply to the Innovation Factory, because even though the Innovation Factory does, let's say, pitching competitions that might be centered around an innovation hub like Skolkovo or Estonia, or we did one in Cape Town, you can apply to it all year, and then the solutions are evaluated, and the best solutions have a chance to pitch. So if you go to aiforgood.itu.int, and there's a tab called Engage, there you can directly apply to the Innovation Factory. And I hope you do so. Thank you.
And so anything which is good content, you know, we're happy to feature, you know, whether it's experts, whether it's startups, whether it's researchers from companies or universities. You know, we have a huge amount of content, very good content, not fluffy content. And so if you're interested, please let us know. We're happy to get in contact with you. With that, perhaps I will move to my presentation. So I will talk to you about the activities of ITU with respect to artificial intelligence and in particular machine learning. Next slide, please. And you are aware that we have so-called, you know, study groups. This is where our recommendations, our standards are being produced. Then we also have another group, which we call focus group. So this is more of a pre-standards work. And the way it works in practice is that what's being developed in the focus groups, the specifications that come out of a focus group, is pretty much always forwarded to a study group, and then the study group turns the specification into a standard. Anyone can participate in a focus group. You don't have to pay. You don't have to be a member. You don't have to pay anything. It's wide open. We usually run half a dozen focus groups at the same time. And here on the slide, you see 5 focus groups listed, which have AI or machine learning in the title. So AI is clearly a technical topic that's dominating our work right now. And I think this will continue for some time. So I will focus in my presentation on, I will give details on all of this focus group, but I will focus in particular on the work that we do together with the World Health Organization on AI for health. I think this is one of the most exciting areas of work that we do in ITU. And I think that not just relevant for what's happening in ITU, I think overall this is really a super exciting piece of work. We also have a somewhat looser collaboration that we name global initiatives. And so I will also mention two of those that are bubbling up. Next slide, please. Our first focus group is called, or was on machine learning in 5G networks. For 5G, you can read communication networks in general. We started with that work already some 4 years ago. And I think it's probably fair to say that ITU was really arguably at the maybe cutting edge, being really one of the first that looked at standardization aspects of machine learning. Next slide, please. The focus group has turned out 10 specifications, and they have all been forwarded to the study group 13 to turn it into recommendations. And I think it's about 6 specifications which have already been turned into ITU standards, which we call recommendations. Next slide, please. The most important standard is the architecture framework for machine learning in networks. And here is like the key diagram where you see that the architecture has 4 main parts. It has an underlay. The underlay can be 5G, 4G, Wi-Fi, it could be any network. Then there is a pipeline system, and the pipeline is just a bunch of nodes and a bunch of logical nodes. Each of those nodes have a special functionality, and you can piece together those nodes to form a machine learning application to run in a telecommunication network. Then there is a sandbox, and the sandbox is simply a testing environment for machine learning algorithms in a network. It allows you testing your machine learning model using real data and evaluate the AI models and its impact in the network before you actually allow it to go on the network. Now, in communication networks, you have very many different timescales. Timescales may be on the order of a year, which is like the subscription to your service provider, but it could go down to 2 minutes, 2 seconds, to milliseconds. So depending on the time scale, you may actually have to retrain your algorithm on the second or even on a millisecond time scale. So your sandbox could be really busy, could be busy on a second or on a millisecond time base. And once then the operator is satisfied with the testing, then the model would be deployed in the underlying network. Another component is the brain of the architecture, which we call the machine learning function orchestrator, MLFO, machine learning function orchestrator. So that's again a logical node that manages and orchestrates the nodes in a machine learning pipeline. But ITU did not just write an architecture standard and related standards, but we're actually also running a challenge, a competition to apply machine learning 5G to real problem statements, to apply the framework that the ITU has developed. And my colleague Thomas will talk about this in the third part of our presentations. Okay, so next slide, please. Okay, so this is on AI for health. And as I said, I think this is really a super exciting work that's happening here. And not just super exciting for ITU, but I think if this turns out to be a successful project, it's going to have really a huge impact. So, the way I usually start my explanation is of what the group is all about is why would you trust an AI solution, especially an AI solution in the health sector? And why do you trust the traditional, why do you trust medication? Why do you trust doctors? And you trust doctors or you trust medication because you trust the process that has been developed over the decades. You trust the institutions, you trust researchers, you trust the regulators. So you have a certain trust created towards doctors and medication. But what would it take to trust actually an AI solution? Next slide, please. And so this is what is key here. In order to trust AI algorithms, AI models, you have to have validation criteria, you have to come up with metrics, you have to have data with which to test that. The models should be explainable, they should be robust, and they should also be able to understand or to give you a certain level of uncertainty, like error bars. The training data, the testing data, they need to be representative. They should not be biased. They should also reflect the characteristics of the population with respect to gender or age. They should also be able to reflect the differences in equipment and hospitals. You know, if you take an X-ray with one machine, and then you take an X-ray with maybe a machine from a different equipment manufacturer, you would still want to be able to be transparent with respect to which company has provided the X-ray machine. Also, with respect to different hospitals, that should be transparent. One big bottleneck is the availability of annotated data. Data that mark, for example, here is I think a blood smear, whether some region may be cancerous or maybe not be cancerous. And this is actually, and I'll come to this in one of my later slides, a non-trivial problem, the annotation of data. Next slide, please. So what the group does is two things. The group is going to develop what we call a benchmarking framework to assess the quality of AI models. But then in addition, and that's really the cool part about this group, it's also going to develop what we call an open code, open source platform to assess the quality of AI for health solutions. Next slide, please. So before I talk about the platform, the AI for Health Assessment Platform, our open code initiative, let me give you an overview of how we structure the work on AI for Health in this focus group. So we have a matrix structure. We have so-called topic groups, and we have actually 24 of them right now that feature on a particular problem or disease in the health sector. So we have a topic group on tuberculosis, we have a topic group on dermatology, we have a topic group on dental topics, we have a topic group on diabetes, and also topic group on ophthalmology. So we have 24 of those. And then we have so-called working groups that will produce documents which are relevant to each of those topic groups. So each of those topic groups, will have to consider the data and AI solution assessment methods. They will have to consider ethical considerations. They will have to consider regulatory considerations. They will have to consider how to evaluate results clinically. So this is the way how we organize our work. And next slide, please. And then we have our open code initiative, which will offer a pipeline, an end-to-end pipeline that will evaluate AI solutions. So this platform is determined for, can be used by companies that are developing AI solutions. It can be used by doctors, it's supposed to be used by regulators. And the vision of this platform is not only that we just build tools, but that we also assess the quality of the AI algorithms in the health domain. There are various AI evaluation platforms out there, and but we focus on healthcare exclusively, and we think that we are doing perhaps maybe a better job in going into the challenges, the difficulties that exist if you offer a evaluation platform in the health sector. So we will offer a end-to-end solution. It starts with the data acquisition. How do you actually get the data onto the platform? How do you store the data in a secured way? How do you prepare the data for annotation? How do you do inference? How do you test the various algorithms, the various models? How do you then evaluate them? And at the end, we will also have a report, and that's something perhaps that could be used by a regulator. We do have a test case. Our first test case is diabetic retinopathy. So, some people with diabetic have an eye disease. Their retina is somehow different, and this is a case that has been cited in the literature. There is quite a bit of amount of analysis available, and this will be our first test case with which we will test our end-to-end pipeline. Next slide, please. Just to give you a feel for some of the the challenges, the difficulties that you have to think about when you want to come up with an AI evaluation platform, is the area of annotation. So annotation is at the core of so many machine learning applications, and there will be lots of different use cases for us, and we need to be able to account for that complexity. And we want to provide an annotation process which relies on external expertise. So, there are some powerful software packages available in the market, but we think what is missing is the processing part. And I will explain what that means. So, suppose you have data available. Let's say you have some maybe X-ray images of breast cancer. Then, first the decision that you have to take is which images do you actually use to evaluate or to train or to test your model? Would you take all of them, or would you take a random selection of those images? It is often the case that experts disagree on the interpretation of an image. So what do you do if you have different experts telling you different things? So you could have, you could simply take a majority rule, but that may not always necessarily be the best solution. Perhaps you have an expert who is really like the expert, and her opinion differs from what everyone else says, but they are not as good as she is. So you have to think about what is actually the best way of getting an agreement on what an image means. And so we are going to provide a feedback loop where these experts can discuss. They could also recalibrate. And then at the end, we hope that we come up with a ground truth which is satisfactory. So there's quite a bit of software needed, which many tools do not provide. The annotation workflow is quite complicated, but our tool will take care of that. Next slide, please. So, not to go into detail, but just to tell you that this is real here. So here is an architecture, or here is the architecture of what the benchmarking framework is going to look like. We are going to store the data on AWS, on Amazon Web Services. Next slide. This is just to give you a feel for the tools which we are using. So GitHub is the main repository, and then there are a bunch of other tools that you may or may not have heard of or know of, depending on which area you're working in. Next slide, please. So we are in phase number 1. The project was started at the beginning of last year in 2020. And so we are coming to the end of the first phase, which we also call the prototype phase, by the end of the year. And then we want to scale up. We want to turn this into a real world-class platform. And for that, we will need major funding, and major funding probably means a few $million, euros, Swiss francs. But so far, a lot of people have been working on this, investing their time, their know-how into this platform, and it's really taking shape. So this is really, I think this is really fantastic what's happening here in this focus group. So everyone is invited to participate in focus groups. As I said, they're for free. And if you're interested in getting involved in any aspect, whether you're a doctor or an engineer or a regulator, it would be great if you could join this initiative. Okay, so I was going in some depth into the work of the AI for Health focus group that we do together with the World Health Organization, but I thought this is just so exciting that I need to explain this in a bit more detail. Next slide, please. Okay, we have another focus group that's called the Focus Group on AI for Autonomous and Assisted Driving. And the work of this focus group has expanded somewhat. Just 2 weeks ago, we launched a AI for Road Safety global initiative, which is actually broadening the topic that the AI for Autonomous and Assisted Driving focus group is working on. Next slide, please. So if you want to drive a car, you need to take driver's lessons, you have to take a test, and then you get a license. But the driver of the future, and actually even currently, is going to be more and more software. So what are the tests? What's the driver's test that the software would have to take in order to get a license, so to speak? And this is the topic that our focus group is going to work on. We have collaboration with a United Nations sister organization called UNECE, European Commission for Economic Commission for Europe, which for historical reasons plays a major role in the regulation of vehicles. Next slide, please. Next slide, please. Okay, yeah, sorry. Okay, no, you had it, yeah, sorry. So again, you're invited to participate. We have our next online meeting in December. There are various specifications in the works, and I listed a couple of them here related to an automated driving safety protocol. So this is part of the work that the focus group is doing. Next slide, please. So 2 weeks ago, we launched a global initiative on AI for road safety. And we're doing this together with the United Secretary General's envoy for road safety. So that's a person, an envoy, that's a person, a single person. that has been nominated by the United Nations Secretary of General. And if you are into cars or into racing cars, then you know the name that I'm going to mention now. So the United Nations Secretary General Special Envoy for Road Safety is Jean Todt. So he played a key role in Ferrari, at the time when Michael Schumacher was winning his world championships. Another partner is what's called the UN Envoy on Technology. We also have other partners such as UNECE on board. And with that, we launched the Air for Road Safety initiative. Now, what are the objectives of this initiative? One of the UN targets within the Sustainable Development Goals is to reduce the road mortality by half. And you may have heard the statistics that worldwide about 1.3 million people die on roads every year, and then the number of injuries is much, much higher. It would be really good, to have, knowing where and when these accidents, these road traffic crashes happen. But unfortunately, in many countries, there is little or no data available on road traffic crashes, and no means to actually, analyze the data and then to identify what could be effective solutions. So therefore, a major aim of this global initiative will be to ensure that there will be equitable access to data, and also ethical use of algorithms across all safe system pillars. We want to be able to identify the various elements that influence road safety and highlight and see the role that AI can play to enhance the crash data collection and analysis, to enable that there is a more effective post-crash response, and that may then also give some ideas for more appropriate regulatory frameworks in the transport sectors. So these solutions will be in particular of interest to low and middle income countries, where most of the road fatalities and injuries actually occur. Good. Next slide, please. Okay, so this is our focus group on AI for natural disaster management. And next slide, please. This is a group that we are running together with the World Meteorological Organization and the United Nations Environment Program. That's a group that's developing best practices on how AI can help mitigate, predict various disasters or catastrophes, natural disasters, natural catastrophes, such as floods or tsunamis or landslides or snow avalanches or volcanic eruption or wildfire. Again, this group is also open. You can participate at their next meeting, which is actually tomorrow. Next slide, please. This is our focus group on AI for environmental efficiency. Next slide, please. So this is a group that's looking at the environmental efficiency of technologies, not just AI, but also technologies such as blockchain. The group is developing requirement specification to make sure that everything is environmentally efficient, how this can be measured, and then provide implementation guidelines. We had a number of workshops on this topic. The next one will take place also tomorrow. And then you could also participate in their next meeting, which is the day after tomorrow. Next slide, please. Okay, now I'm coming to the last piece of work, which is again branded as a global initiative, and that goes by the name of the AI and Data Commons global initiative. Next slide, please. So we're all familiar and we all use, I think, a collaborative platform such as Wikipedia. And if you are into programming, you are also maybe likely to use a platform of GitHub. So these are platforms that are run by whoever is interested, whoever cares about these topics. And this is just a fantastic resource that's available. In the case of Wikipedia, for anything that you ever want to know about any topic, GitHub is just fantastic if you are a software developer. So here we say dream. What about if we could have such a collaborative platform also in the area of AI and data science? This would be a platform that could match problem owners with solution providers. The solution providers, they may have know-how of AI. The problem owners may not need to know AI, but matching those tools could provide solutions to what the problem owners are after. It would be a platform that would make available resources in the sense of know-how. There would be available data sets, there would be available AI models, and it would be a platform that could increase the visibility and the reach of existing standards or specifications, reports, guidelines. So that's the dream. And it's a very ambitious project. That's even more ambitious than the project that we have with the AI for Health assessment platform. But we have a community that's actually thinking about that. And so if you are interested in joining that work, then we will have a episode coming up at the end of October. I want to put this on the slide here, with which we try to brainstorm further on how this could turn into reality. So with that, I would like to close the overview of the work, of the pre-standards work, if you so will, of ITU in the area of artificial intelligence. And if you have questions, I'm happy to take them now before we would go to the third part of the presentation, where my colleague Thomas will explain how our competition, our machine learning and 5G challenge works. So are there perhaps any questions? I'm looking at the chat here. I don't see anyone right now. Call up my translator in case someone types something in Russian.
Добрый день, да. Я вижу в чате есть среди удаленных участников вопрос, и потом будут вопросы в зале. Но я бы предложил, если будет третья часть, то, может быть, заслушать 3 части, а потом обсудить, чтобы не делать перерыв. Как, Рейнхард, удобней?
Yep, that I have, me personally, I have something else in about 15 minutes, so I may not be available for the question part at the end. So if there is something that you would have on this particular pass right now, then I would answer that right now.
Хорошо. Большое спасибо за это время, которое вы нам уделяете. Тогда я тут записал 2 вопроса и потом передам уже другим участникам. Начну тогда, пользуясь своим служебным положением, с себя. Мы все знаем, что в секторе стандартизации основной рабочей площадкой являются исследовательские комиссии. Именно они разрабатывают стандарты, которые ложатся потом в основу нашей работы в телекоммуникациях. Очень интересный и формат проведения саммита AI for Goods, и мы принимаем в нем участие также, и очень много видим выходных материалов. Вот первый вопрос связан с тем, какая взаимосвязь существует между AI for Goods и исследовательскими комиссиями, как наполняется работа исследовательских комиссий результатами AI for Goods. Вот это первый вопрос. И второй вопрос сразу озвучу, Рейнхард, если удобно, пометьте. Второй вопрос: планирует ли МСЭ внедрять инструменты искусственного интеллекта для собственных нужд, для анализа статистики? Ведь в МСЭ очень много данных, входящих, выходящих. Сейчас секретариат тратит очень много времени на работу с ними. Может быть, переводы, что-то, может быть, уже рассматривается для того, чтобы искусственный интеллект мог помочь нам в решении общей задачи. Спасибо.
Okay, I'll take the first question. So what's the relation between the AI for Good platform and the work that's happening in the study groups and the focus group? It turned out that the AI for Good platform is sort of an incubator for work that will get started in the standardization sector. So the focus group on AI for Health that I mentioned is a direct outcome of our AI for Good Global Summit in 2018. Also, the work on the autonomous and assisted driving, this focus group, is an output of our AI summit that took place in 2019. The current, if you go to our website, you will see that we have a large number of content related, for example, to machine learning in 5G. We have around 50 sessions where we have researchers from universities, from companies, speak about their latest research with respect to communication networks. And actually, as we speak, this week, there is another proposal coming to the study group 20 on launching a focus group together with FAO, the United Nations organizations with respect to food, on digital architecture, on AI and IoT in the realm of digital architecture. So the AI for Good is sort of an incubator for interesting work that the ITU can do, but also that we do together with other with other organizations, UN organizations. With respect to the questions whether we use AI tools in-house, yes, we are. And I think the most very important part of the machine learning tools that we're using is in the area of translation. So, language is always an important topic within ITU. We just don't have the budget to translate all the specifications into the 6 UN languages. So, but with machine learning translation, we can do a lot more. So we actually do a lot of translation work assisted by machine learning tools. Then my colleague Fred mentioned that we're going to offer also within the AI for Good platform a networking solution. So we are also going to base that on the machine learning algorithms that will be able to match different participants with each other. So yes, we do. We make use of machine learning in-house, and I think this will only increase over time.
Спасибо, Рейнхард.
Maybe maybe I could actually even go, a step further. It's an interesting question how machine learning would impact the work of standardization itself. Right now, the way standardization works is you have companies join an organization like ITU or other standards forums and consortia, and then there is a negotiation process to come up with an agreed upon standard. But you can think of using perhaps machine learning and actually coming up with maybe with some protocols, and that's also actually being looked at. So I think the impact that machine learning will play in standardization is also going to change the way standards are being done today.
Да, большое спасибо, Рейнхард. Я как раз слушал вас и думал о такой тонкой материи в МСЭ, как консенсус. Поможет ли искусственный интеллект нам достигать его более эффективно? Это такой один из самых sensitive моментов, чувствительных моментов в нашей работе. Есть ли в зале вопросы? Да, сейчас...
Благодарю, господин председатель. Хотел поблагодарить докладчика. Очень интересная информация о прогрессе в столь противоречивой теме. Вы рассказали большой материал, касающийся использования искусственного интеллекта для здравоохранения. И я хотел бы спросить следующее. Сейчас параллельно нашему собранию идет собрание исследовательской комиссии 2 сектора развития электросвязи, и вопрос электронного здравоохранения там является одним из очень важных в обсуждении, особенно в связи с печальными событиями пандемии. И хотелось бы спросить, ведется ли какая-то совместная деятельность между двумя бюро, как на уровне секретариатов, так и на уровне исследовательских комиссий, фокус-групп. И если нет, то хотелось бы предложить наладить этот обмен как можно скорее для того, чтобы мы шли от стандартизации каких-то решений в секторе стандартизации электросвязи к их применению и к передаче информации и ознакомлению для конкретных стран и о том, как это внедрять в национальное регулирование, что очень важно, особенно для развивающихся стран. Спасибо.
Yeah, and it would be great if we could feature those use cases on our AI for Good platform. So that would be fantastic. If you have experiences on the ground in the field on how AI can help make the life of us easier, that would be great. Very happy to feature that on AI for Good.
Спасибо большое за интересное выступление. Очень много новой информации можно было почерпнуть из вашего доклада. Я хотел задать вопрос следующего содержания. Сейчас активная работа по тематике искусственного интеллекта и технологий машинного обучения, нейронных сетей ведется не только в ITU, но и в ряде других международных организаций по стандартизации. В частности, в GTC-1 ведется работа по искусственному интеллекту и разработке стандартов по этой теме. Значит, активное направление, связанное с применением искусственного интеллекта для интернета вещей, цифровых двойников. Я хотел узнать, вот традиционно в первой стадии разработки любой рекомендации международной является ГАП-анализ. И вот хотел узнать, вот в рамках Международного союза электросвязи проводите ли вы работу по анализу того, что делается по тематике искусственного интеллекта в других организациях, чтобы почерпнуть этот опыт, чтобы использовать наработки других, соответственно, комиссий и организаций в этой сфере? Спасибо.
Mm-hmm. Yeah, when our focus groups, they have as one of their objectives in their what we call terms of reference to look at the work of other organizations. And I mentioned some examples where we collaborate with, in this case, UN organizations like the World Meteorological Organizations, United Nations Environment Program, the UN ECE, the World Health Organization. The amount of work or the area is so huge. I mean, there are like thousands, tens of thousands of use cases that you can imagine with AI or IoT. So I think the University of Moscow would not say to the University of St. Petersburg and say, we are working on AI, you cannot work on AI. I mean, that just doesn't make sense. Yeah. So all the standards organizations are going to will be working on AI in some area. And sometimes there is collaboration. I mean, we have in some of the work of the study groups, very close collaboration, for example, with ETSI, the European Telecommunication Standards Institute, with IEEE, also with ISO, IEC, JTC1. So some areas we work very closely together. In other areas, we don't work closely together, and there are different people, different thoughts, different use cases, different requirements that come up. So there is sometimes the argument of overlap comes up. I'm not sure whether you're alluding to that. But I think this is a non-issue. Thank you.
Большое спасибо, Рейнхард. Еще один вопрос у нас тут поступил. Он связан скорее, в принципе, с рассмотрением структуры работы сектора стандартизации, в том числе в части, касающейся искусственного интеллекта. Вы помните, что на прошлых собраниях консультативной группы по стандартизации был вопрос такой о возможном создании исследовательской комиссии по искусственному интеллекту, которая бы вобрала в себя направления работ, которые сейчас рассматриваются в фокус-группах, в том числе те исследования, которые проводятся в рамках AI for Goods. Как, может быть, вы считаете, исходя из работы, вот зрелость этого направления уже в какой степени находится? Спасибо.
That question I don't quite understand, Alexei. Can you explain again what you are?
Да, Рейх, спасибо. Я, наверное, слишком переусердствовал в осторожности, формулируя вопрос. Вопрос был в том, что некоторые страны и регионы предлагают создать исследовательскую комиссию study group в секторе стандартизации. И мой вопрос был связан с тем, готов ли сектор к такому, как вы нас воспринимаете, будучи в секретариате, зрелость этой темы, насколько она в текущее время созрела для того, чтобы уже была целая ИК, которая бы разрабатывала стандарты.
Are you referring to an idea that's being discussed about having a consultancy do an analysis? Is that what you're referring to? Or
Нет, я говорил о том, что многие предлагают создать исследовательскую комиссию в секторе стандартизации по вопросам искусственного интеллекта. И наши страны в том числе интересует вопрос, насколько эта тема сама по себе готова к тому, чтобы была отдельная исследовательская комиссия.
Rainer, I may help.
Okay, that I haven't heard about a research commission related to AI. That I don't know. I don't know the details about that. I've heard about hiring a consultancy to look at maybe the way the study groups should be structured. So I think that's being discussed by some of the members. Yeah, which I think members. I don't really see what that would add. I think it's the members that have to come up with a conclusion and a decision on what they would like ITUT to work on. At the end, it's always contribution driven. If nothing is coming from the members of ITU, then the work will not get done. So yeah, I think that's maybe all I can say to that. But maybe we can also maybe discuss offline. Maybe I'm happy to learn some more things about what you just said.
Спасибо большое. Да, я тогда бы еще смотрю, у нас есть вопрос от удаленного участника. Амар Мутхана, вы можете взять слово, Амар?
Yes, thank you. Thank you for the. I have a small question that you have very too much like solutions, data set and code in all these areas, and is that available researchers for students?
My colleague Thomas will talk about that. We are in the process of, within the context of our machine learning challenge, we are in the process of developing a platform that would allow compute resources and that would also allow for the storage of data. So we are not there yet, but we will be getting there. I mean, we learned from running our machine learning challenge last year that quite often countries or not universities, companies may not necessarily have the compute resources available that richer countries, richer universities have. So we try to tackle that problem with our platform. The AI for Health assessment platform, we will make, the entire code will be made available, publicly available, and then people can do whatever they wish to do that. With respect to the testing data sets on the, I guess on any platform, they would not be made publicly available. I mean, they cannot be made publicly available because otherwise it would be too easy to game the process. And so the testing data would also would have to stay confidential. But other data, if we get them and we have the permission, they would be made available for use. That's the goal.
Thank you.
Okay, maybe my colleague Thomas can take over perhaps. And yeah.
Большое спасибо, Рейнхард, за ваше выступление. Мы были очень рады вас видеть. Большое спасибо.
Thank you. Thank you. Thank you,
Да,
Alexander.
Томас, пожалуйста.
Thank you so much. Right now, we are going into the third part of the presentation. So my name is Thomas Bascolo. I'm working with Reinhard and Fred in the ITU on the topics related to AI and machine learning. And on this part of the presentation, I will talk about the ITU's AI and machine learning 5G challenge. Next slide, please. So, as highlighted by Reinhard in the previous presentation, there's several focus groups that has worked on AI-related or machine learning-related topics. One of the focus group being the focus group on machine learning 5G. And this focus group ended in last year, around July 2020 is when their lifetime was ended. But they produced 10 specifications, which was forwarded to their mother study group, which was study group 13. And some of these specifications that was developed by the focus group were turned into recommendations. Now, the discussion is, it is nice that we have these standards, and most of the standards, well, some of them are on paper, but how can we put these standards into best practice? So what we discovered was that I think it can be good, it would be nice to have a competition in which we'll use these standards to produce open source solutions. So the competition is what we termed machine learning 5G challenge. This challenge is specifically on topics related to communication networks, how we can apply machine learning or AI in communication networks or in future communication networks. And in this challenge, we are targeting everyone, all members of the ITU, whether students, professionals, anyone can participate in this challenge. Next slide, please. So why do we have the challenge? As I have already highlighted, we want to provide open source solutions to the standards that are being developed in ITU. Of course, we cannot have open source solutions for all standards. It is so much work because we have several study groups working on different topics. But in this case, we specified on machine learning that are applied to future networks. So that's what we decided to work on. And this is the challenge that we are having. And in this challenge, what we would like to achieve is to create a community of value, to have a community where everyone is on board with the same objective, where the value will be open source solutions or solutions from machine learning that will be applied or that will be applicable to 5G that can be used by members of the ITU. And this can be, it's more or less like a cycle where you have the standards will inform what kind of work we need to do in the challenge and the solution, the open source solutions. And when you have the open source solutions, we will identify the gaps. Once we identify the gap, it will feed back into the standards work, because then we can identify, okay, in the standards, there are these gaps that we have. Maybe in future, ITU can work on these parts of the standards. So it's more or less like a cycle that we would like to create, where the standards will inform the challenge, the solutions will be open source, and members of the ITU can use these open source solutions, and then we identify the gaps, and then it will feed back into the standards developing process. And also, of course, we would like also to provide practical solutions to network-related problems or to problems that are being identified by the standards, or the problems that the standards would like to solve. At the same time, we also like to engage students as well as researchers. In standards development work, most of the times we have the member states as well as the members, which are most of the times the companies that are part of the ITU. We have academia members, but in most cases, they are not very, I would say, engaged so much in the study groups. So if we can engage as much students to entice or to increase their motivation in the standards work, we may have more academia members, we may have more researchers also joining ITU and engaging in the standards development work. So these are some of the objectives of the challenge. Next slide, please. So the challenge in general, what we are targeting is that we have the students and the professionals, they are competing to solve these problems that are set up by different hosts. And these solutions will inform AI in communication networks. The target, the challenge, what we do currently is that we have almost a year with different phases that I'm going to talk in slides that are coming up. But we have several months. And in these months, we have the first part of the year, we are preparing, we are getting the host to identify which problems we want to work on. And then we have the competition phase where the participants are going to register and as well as to compete to provide the solutions to the challenge. And then after that, we have the evaluation phase, and then we have the awards. So the awards, most of the times, we are targeting in December. For this year, 14th of December is the date that we are having the awards ceremony. Now, during this part of the year, we have several activities that are happening. We have webinars, we have expert talks, we have mentorship where we guide, if, for example, students are not familiar with the problem set, we have like guiding sessions where we guide them to work on the problems as well as to have the solutions so that they compete fairly with the researchers, because some of the researchers are seasoned researchers. They have worked in the area for quite a long time. They're competing with students. Maybe these are undergraduate students or master students or PhD students. These are different levels of experience. So we do provide mentorship so that the students also compete favorably with the seasoned researchers. Next slide, please. Now, on this slide, we have a video to just highlight about this year's challenge. So I'd like, maybe you can play the video. So it's about 40 seconds. Maybe you could add the audio. I think this is audio.
Наверное, без звука все-таки будет. Без звука. Включается. Я могу английский канал включить и будет.
Yeah, it's okay. Play the video. Yeah, so this is just an advertisement for the 2021 challenge, and we have several things that we are talking about in this video. But just to inform you that the registration closed. Currently, we are receiving the solutions for the 2021 challenge, and participants are in some problem statements. The participants have already finalized submissions, and we have the rankings ready. In other problem statements, we are still receiving the solutions. So in the next slide, I just want to give a highlight on the 2020 challenge. So the challenge, the first edition was in 2020, and in 2021, we have the second edition. Now, these are interesting statistics for 2020, because if you can see, we have more than 1,300 participants who contributed, who registered to participate in the challenge, and they formed 911 teams. These were from 62 countries, and in this challenge, we had 11 hosts. So host is I would say it's a university or a research group or anyone who has a problem set that, or more or less like a homework that gives to the participants to work on, to provide the solutions on. And in 2020, we gave out 33,000 Swiss francs in prizes to winners from different teams and from different countries. And these were based on more than 10 ITU recommendation and specifications. And an interesting part was that we had over 100 solutions, and out of these 100 solutions, more than 30 open sourced. So you can access the code, the slides, the explanation, the report on different GitHub repos. If you go to the challenge GitHub repository, you can have these code and they're open source. You can base your work if you are a telecom operator, or maybe you like to, maybe it's a researcher who would like to use part of the work from the solutions that were submitted for the challenge, you can access them freely, openly in the GitHub repository. So these are some of the success stories from last year, and the challenge is continuing this year. So as I already said, we are in the middle of the 2021 edition of the challenge. So next slide, please. Now, as part of the challenge, we have several activities that also accompany the challenge. We had a special issue in the ITU magazine, and also in 2020, we hosted a special issue for the ITU Journal for Future Networks, and 10 papers have been published in this special issue. The special issue was out in September, so that was the September issue of the ITU Journal. And in this special issue, we have different topics such as explainability of machine learning. We have the graph neural networks and several other different topics that have been published. And also we have advertised for a new special issue. This is the second edition. This also on the ITU Journal, Future and Evolving Technologies. The deadline is 31 January 2022. So if you are a researcher, you are working on these related topics, you'd like to submit a paper, the call for papers is out and you can start submitting your 5G solutions. So these are some of the interesting things that are happening with the challenge. We have academic papers that are also coming out of the challenge. Next slide, please. Now, I would like also to take this time to mention that Xilinx is the sponsor for the 2021 edition of the challenge, and this is organized by the ITU. And of course, we have several hosts. It can be mentioned in the next slide. So if we go to the next slide, you can see the problem host. So what is a host? In general, it's an institution or it's an organization that provide the homeworks. Let's use the problem as a homework. So you provide the question or the machine learning problem that you like the participants to work on. When you pose this problem and give it to us, you are the host of the problem statement. Now we take this problem statement, we share it with the participants, we share it to everyone, and everyone else, it will be open to everyone to work on the problem statement. So this year, we have several problem statements host, including St. Petersburg State University, who is a host in Russia. And they were also part of the challenge last year. We are thankful for them for being part and parcel of the challenge. And of course, we have this year technical partner, AIA from China, who are providing us with the front-end platform where participants can register. You can see all the information about the problem statements. Next slide, please. So we have 14 problem statements that are happening currently underway. And I would like to highlight maybe two, because I understand our colleagues from St. Petersburg State University, they are going to highlight their problem statement, which is problem statement number 10, on forecasting model for series allocation network using traffic recognition. So in this presentation, I would like to highlight two. One is problem statement number one, which is on the bottom. You can see graph neural network challenge, creating a scalable digital twin. So in this problem statement, what the host is deciding to achieve is that they want to create a digital twin. You, as a participant, participants will be required to train a graph neural network that the training nodes will be 50. But in the testing or in the implementation phase, it should be able to generalize to a network with more than 300 nodes. So what happens is that, if, for example, in a test bed, you cannot have a test bed that is as big as a real network scenario. But when creating a digital twin, you want to have a better model that can generalize in real world. So that is what they are trying to achieve. And some of the solutions that we have seen so far, they have achieved a mean error rate of less than of about 1.2%, which is very good solution. And another one is problem statement number 14, build-a-thon or proof of concept, network resource allocation for emergency management based on closed loop analysis. So in this case, we are working hand in hand with one of the focus group, which is focus group for autonomous networks. They are creating, it's a proof of concept that they would like to achieve. This will be a focus group work once everything is done, but they have segmented it to be part of the challenge where teams are building a closed loop that can be used as a proof of concept for the focus group. So you can see that the challenge itself is also working hand in hand with pre-standardization activities and can also feed into these activities by creating proof of concepts for some of the work that is done in ITU. So these are just some highlights or some examples of what is happening. Next slide, please. So this is the timeline. We are in the competition phase, which is June to October. And then from November, we have the evaluation phase. And in December, we have the awards ceremony. Next slide, please. And we have, as I already talked about, we have several webinars, several talks that are happening on weekly basis. Languages, we had some in Japanese, Chinese, Portuguese, and also would like to have maybe in the coming future, we'll engage our colleagues in Russia to have some of these webinars in Russian language so that participants from all over the world can access these materials easily and in their local languages. Next slide, please. Now, I would like to, before I finish my presentation, I'd like to highlight on how you can participate. So there are several ways you can participate. You can be a host of a problem statement. As I already highlighted, St. Petersburg State University is one of the host of problem statement. So if you are a telecom operator, you are maybe your company or your institute can also host a problem statement. You can also participate to provide, you can be a participant by providing solutions to some of the problem statements. You can sponsor the challenge. You can be part and parcel of the challenge management board or the judges panel. And also you can speak at one of the webinars in the Discovery series. So these are all different ways that you can participate. You can in the challenge. Next slide, please. And as already pointed out by Reinhard, we are also preparing the sandbox. This is a testing environment where participants will be able to train and evaluate their machine learning solutions. This will be free to all participants of the challenge. We are still trying to work on the software implementation so that it should be publicly available. Next slide, please. Now, if you need more information, you can visit the challenge website in AI. This is under AI for Good, AI, ML, and 5G challenge. And also we have the central platform where all the problem statements that are being worked upon in this year, they are listed. You can check these two websites. You have all the information about the 2021 edition of the challenge. So I think next slide is the last one for me. You can join us for the 2022 edition of the challenge by hosting a problem statement, being part of the challenge management board, sponsoring the challenge, and in another way possible. Maybe I can take some few questions. I know I'm out of time, but maybe if there's some questions, we can just take a few questions. Thank you so much.
Томас, спасибо большое. Да, не скрою, ваш доклад вызвал оживление и в чате, и в зале. И я сначала попрошу вас по возможности эти две ссылки, которые вы привели на предыдущем слайде, если вам не сложно, отправьте их в чат, пожалуйста, чтобы люди могли скопировать сразу, потому что это был один из вопросов, где найти линк, где посмотреть информацию. И этот ответ ваш, он был как нельзя кстати. Чтобы все окончательно уточнить, правильно ли мы понимаем, что ITU формирует ограниченное число проблем, и организации стремятся выбрать себе одну, которая им близка по профилю, и с ней работать. Так? Или организации сами могут предложить какую-то проблему, ITU может признать ее важной и включить в список проблем? Томас.
So thank you so much for the question. The organizations are proposing a problem that is related to machine learning in future networks. So any problem that you think is relevant for the organization and is relevant for ITU is welcome. So we curate, we take all these problem statements, bundle them together. We will have like maybe problem statements that are proposed by our colleagues from Russia, our colleagues from China, our colleagues from Brazil, from US, from all over the world. We bundle them and we advertise them together. And then anyone who is interested to solve that problem that your organization has proposed will provide the solution. That's how it works. So in general, ITU does not propose a problem. We just get problems from members, and then members also solve these problems.
Спасибо, Томас. Все очень четко, понятно. Вы ответили на этот вопрос. Второй вопрос связан с тем, в 2022 году, когда страны и организации могут подавать свои предложения, до какого числа?
For submission of the proposals, we have started receiving proposals now. Normally until April, that's where we stop receiving the proposals. But we have started engaging and receiving the proposals. So anytime from now until April of next year, we can receive these proposals and work hand in hand so that we have good time to advertise and also to make sure that everyone knows what kind of proposals we have for 2022.
Большое спасибо, Томас. Есть ли вопросы еще, коллеги? Удаленные участники, я тоже не вижу запроса. Большое спасибо еще раз, Томас. Это была интересная часть доклада, она заинтересовала наших участников. Я думаю, что все уже пошли готовить заявки. Большое спасибо. И следующим докладом
Thank you so much.
Хотел бы пригласить следующего участника по повестке. Так. Это представители Санкт-Петербургского государственного университета телекоммуникаций. Да, дистанционно. Амар. Амар, я вас вижу. Микрофон ваш, пожалуйста.
Спасибо большое. И я буду докладывать на английском языке, потому что у нас international command. So I can share my screen, I think. Thank you very much. So our presentation also consists from 3 parts. First, I will try to give some small, like about our department, about some research areas, and also about some solutions which we solve in based on this topic. And then my colleagues, Dr. Abdul Hamid from Egypt, he is now also postdoc in our university, and Artyom Volkov is PhD students from our department, will continue my talk. So first topic is dynamic service migration, distributed edge computing. I will start with Artyom to talk about this field, and then my colleagues Abdul Hamid will continue with artificial intelligence empowers the future of unmanned aerial vehicles, UAV, which hope will be the next suggestion for next host challenge in this challenge. So this also immigration microservices is based of one of the challenge which I will talk about later. So first about our department is we are from the famous international scientific school Professor Andrei Kucheriavi, who is the chief professor of the department communication network and data transmission, which was founded, this department was founded in 1998. And in our department, we have, I think, more than 6 doctors. More, this is statistics from a few years ago. And also we have around 40 PhD students, and also the papers per year, which including in journals, conferences, which we organize in our university and then participate based on in different journals. So we have also an experience in we founded the conference in Thitan. We also organized S7DS last year, and also we have this year workshop from this conference. Also, our department have experience of ITU recommendation develops. So what hands-on experience? Our experience, we are working with many tools, with many devices. We started work with Internet of Things devices from 2012. We had working with many kind of Internet of Things devices, like Raspberry Pi, Node MCU, and so on. And also we have solutions in the modern tactile applications like tactile internet, and we develop this kind of hand in our department, and also remotely we can using remotely we can remotely work with this through the network. So our task is to solve problems with latency, with network parameters, and also we are working with open source solutions like OpenDelight. I mean this controller for software-defined networking, and also at the platform UNAB, which we are, I mean, which consists from, it's open source. We are working with this platform like which include the orchestration, software-defined networking, edge computing, and NFV, network function virtualization. This is like software networks, virtualization networks. This is the topic which we are going to talk about this in this presentation. So our lab consists of these parts. We have through API REST our service plan. We have the control plan. We use OpenDLite platform. And we have switches with Mikrotik, which support OpenFlow 1.0 version, and also HB ROB, which support Adin 3 version OpenFlow. And also our part is consists from data plan, like DWDM platform, and many applications like Internet of Things applications, AR, augmented reality, and holograms, and so on. So we have an experience, like 2 years. We are working in with artificial intelligence, machine learning in 5G challenge, which was in last 2 presentations. And we participate in 2 problems. First was with traffic recognition and long-term traffic forecasting with artificial intelligence algorithms on metadata. We made many webinars in English language, and we are planning to do in Russian language as well for Russian students who are interested to participate. So in this challenge, as Thomas mentioned before, that students will have the chance to work with dataset, which we will share with them, and also we will they will have a chance to work with all these topics. I mean, there are some kind of tasks. Last year, team from UFA from Russia was like they take some kind of prize from this challenge. They was the winner from our host, and they get some kind of prize from this challenge. So next year, we hope to continue with artificial intelligence empowers the future of unmanned aerial vehicles. We're still thinking about this. We will send this proposal, I think so. The same, we will share all this information in our websites. So the main direction of our main direction is robot avatar and ultra low latency communication applications and so on. So, and also software networks, which we are working in how we can use SDN, network function virtualization, edge computing, cloud computing, and so on for all these applications. First of all, I'd like to talk the main category. For example, for 5G networks, we based on ITU recommendation, we have 3 categories like ultra low latency applications, machine type communications, and the third one, like there are new requirements for the future network. For 6G, it will be the same. Like there are higher requirements of reliability and also the end-to-end latency for 5G networks applications. I mean, it's like 1 millisecond latency, and also this is the category for 6G networks. The BigCom basic communication for remote area and high quality conventional mobile communications, and also 3D intercom. There are I mean, new areas with drones, UAV, and so on, which also will be in our presentation. So there are to overcome the traffic load problems, the connectivity, data rate, ultra-low latency. So 5G and 6G networks should employ new technologies. So some of technology should be in the core network, like software-defined networking and network function virtualization, and also another networks that are employed in the edge to offload the core networks, like device-to-device communication, mobile edge computing, and D2D communications. So also artificial intelligence, one of the main technologies, and unmanned aerial vehicles, which can solve all these problems. I mean, some of these problems in future 6G network. We have our experience to work in these fields. First, with mobile edge computing, I think all knows the advantage or the benefits of the edge computing. It's like to reduce the round trip latency, to provide official way of loading, and to provide high bandwidth and so on. And the location of the edge computing is at the edge, I mean, in the base station, or in RNC, in radio network controller. Our solution is we develop a multi-level cloud computing. We develop like this multi-level cloud computing based we develop our uploading algorithms to optimize I mean the uploading. Also we develop that based on different uploading algorithms based on artificial intelligence and so on. And the second part is software-defined networking. And cost-effective network structure. And in this part, we develop our intelligence core networks based on multi-controllers. And this we suggest centralized controller and multi-controllers. We have many applications in this field, and we suggest, for example, one of algorithms like caustic self-swarm algorithms for that. You can check in this publication or in another application. So about D2D communication, we develop the 5G framework based on multi-level edge computing. We add a new level of edge, which called cloudlets for D2D communication. You can check in these papers. Also about artificial intelligence, we have many works. First, we develop like some analytical applications based on metadata, and all our works in last year challenge and it was based on that. We have our data sets which we share for students to develop their solutions. Also, we have also some publications in this field. Also, we suggest solutions at the edge computing. For example, there are when you upload many tasks, it will be some kind of in-hard function, which we solve based on deep learning algorithms for optimization tasks. Other task, another field is unmanned aerial vehicles. We have also some solutions on that. We suggest our system based on multi-level edge computing for that to solve problems with energy and latency, and also we suggest for that uploading algorithms. We develop uploading algorithms for this. This was published in IEEE Access. Another work also we develop our protocol for UAV. So the main topic is today the network softwarization. This definition from focus group IMT 2020 report on standard analysis. So the main ideas is how the network can deploy as the cloud services. The main objectives of this is like to transform the mobile network equipments into virtualized software components. It's called microservice. So also enable the creation and life cycle management of diverse network slices for different verticals. For example, if you have different services like social network, Facebook, we have autonomous vehicles and other services. we can like do different slices for that, also based on this network softwareization. Here we includes edge computing, software-defined networking, and network function virtualization. The definition of microservice is like a logical part of service software, which interconnecting with other microservices in order to provide the service life cycle can be presented by virtual machine, Docker container, and microservice life migration. This is like process which include the following steps: is copy the microservice with current status, fog node definition for migration, allocation of network resources, transfer the microservice copy to the fog for each node, so that microservice deploying microservice connection to service architecture. So in this topic will continue my colleague Artem Volkov. I think you can. Artem, are you there?
Yes. Hear me? What? Hello. Are you hearing me?
Yes, yes, sir.
Да, Артем, вас слышно. Артем. Артем, вы на английском будете выступать или на русском? Просто мы вас пока не слышим.
Сейчас?
Вот, сейчас слышим, да.
Okay. Dear colleagues, I think I will continue in English this presentation. So, as Amar mentioned about that, at this moment we have the new time-constrained services, such as tactile internet, augmented reality, virtual reality, digital avatars, etc. So, and here we suggest to consider deep integrated edge computing and fog computing, and their common infrastructure could give new possibilities and certain abilities. So, and how we're going to do that? We suggest to a framework to distribute computing based on the deep integrated fog and edge with the K-Future microservices architecture support and their live on-demand migration, and use the machine learning and big data algorithms for monitoring the user needs, services load, and optimal microservices migration in order to ensure the necessary service requirements. And use cases you can see on this slide. There are maybe a system of picture improvement based on neural networking, neural network processing for augmented reality, and so on. According to infrastructure technologies, as we know, MT 2020 and beyond will require more flexible network nodes, which are configurable based on SDN architecture and network function virtualization for optimal processing the node functions and improving the operation efficiency of the network. Next slide, please. Next slide, Amar. Thank you. As a general part of the idea in the current work is a microservice approach in software architecture for time-constrained services, where the microservice could represent the different levels of service software decomposition. For example, microservice can be a little server based on MVC, it's a model view control pattern, or independent class model or function, and service decomposition to the function layer is a deep distributed software architecture. This architecture allows services to be distributed across the network on a minimum of 4 devices. And the key features are microservices as a logical part of the service software, the level of service decomposition defined on the software architecture decision layer. Microservices can represent one of the services products, for example, high level of decomposition, and can be represented only by one function of the services. There are neural network, data preparing. It is a very deep level of decomposition. So, and advantages of microservice architecture service decomposition on the autonomic layer. Fast scalability is very important in order to ensure the quality of services. So, and software tools independence, for example, one first microservice can be developed on the PHP, the second can be developed on the Python, and so on. So, and one of the main advantages is the function distribution in the network. So, and according to the microservice migration advantages, there are fast scalability without stopping the main service, the necessary microservice migration based on the user demand, and the group of devices with the few resources using for the service deploying. And if the consumer demands are growing, we can copy the necessary microservices to the closely focused area. And for that, a lot of the tasks we have to solve. In our current work, we consider the general framework processes, and the practical part, we consider the algorithm for the defining the fork nodes for the microservice migration deployment, and the second is defines the center of user clusters. And according to the framework, we suggest the hierarchical system of the connected devices from fork device, which can be dynamic to multi-level edge computing system, which Mark mentioned, and process between them, taking account the user dynamics and microservice support with their on-demand live migration. In our suggestion, we consider the analytical application on the infrastructure service layer as a monitoring and control part of the framework. In addition, this application is divided into two parts: main application, which is deployed in the center cloud, and application which is deployed on the micro cloud of multi-level cloud architecture. And micro cloud is responsible for the appropriate fork zones. Next slide, please. So, and those an application that implement one or another on a user service can be distributed in the network by modulus, considering the technologies of containerization or virtualization. And it's possible to distribute application taking account the needs of each of decomposed modulus on a fork structures controlled by multi-tier cloud infrastructure. And as you can see in this case, here describes how the microservices live migration based on the fork resources allocation. The color of microservices mean the different types of main services. So the next slide, please. This slide shows an example of photo processing using neural networking based on the proposed framework. In this case, a small decomposition of service software is considering to. So, and after the user has taken a photo, it's sent to the nearest fork and distributed to devices with the active microservices, such as microservices with the main database and authorization and so on. And the next step image preparing for neural networking and free copies of microservices neural networking processing. It's a very simple example. And okay, next slide, please. Yes. Regarding to consider framework algorithm in a previous slide, this step of the project considers the two algorithm determine the centers of user conversation, user devices, and searching for more free fork nodes to which the necessary services will be migrated. So, and to search for the user centers, we propose to use the K-means clustering algorithms. This algorithm is characterized by simplicity of implementation and performance. And second sub-process is the process of determining those fork nodes that have free computing capabilities and satisfy the conditions for migrating microservices to them with the subsequent deployment. And within the framework of the sub-process is necessary to solve the optimization problem where given a function describes the state of each fork node through the set of parameters which we defined, and among all possible values of the function, find a value at which the function takes a maximum values. There are many algorithms that are guaranteed to find the extremum of the function, which is a local minimum or maximum near a given starting point x0. So, and such algorithms include, for example, gradient descent algorithms. However, in the problem, it's necessary to find the global maximum of this function that is a given range of parameters. In addition to one global extremum has many local extrema, and in this work it's proposed to use the particle swarm optimization. It's a PSO algorithm, which was inspired by the social behavioral biological organisms, specifically the ability of groups of some species of animals to work as a whole in allocating the desirable position in the given area. For example, birds flying to a food source, and for that we need to define a special fitness function. This function you can see on this slide, and first parameter is determined via the time tracking, the framework, and the second parameter is in the standby device, the processing time of the task. And the result of the PSO algorithm showed that the 13th fork device with the parameters and fitness function value of 0.97 has the lowest required score for further replacement of the microservice on it, and also satisfies the necessary computer networking partition. Also, for example, on one of these graphs, we can see how we can separate the fork zone on microzones and divide it by requirements for each time constraint services. So next slide, please. Thank you. And according to the future plan, the DD fork, which we named, includes the more than presented here research challenges and as well as directions. So, and on the next step of this project is planned to build a predictive model of user routes and service dynamics and so on. For example, monitor of consumer demands, prediction of user routes and their demand based on the monitoring and so on. And thank you very much. It's my talk was about our current work. And Tamar.
Thank you, Artyom. Thank you, Dr. Amar. In the next part of the session, we are going to speak about the unmanned rail vehicles and how the artificial intelligence empower the future of unmanned rail vehicles. As we believe, due to the ease of deployment of unmanned rail vehicles and their flexibility, they are announced as one of the main use cases of the fifth generation cellular networks. And also they are one of the main key enabling technologies of the sixth generation cellular networks. Speaking about the applications of the unmanned rail vehicles, we can categorize all the unmanned rail vehicles apps into two main categories. Unmanned rail vehicles as one of the main use cases of the fifth generation cellular networks, and other apps of the unmanned rail vehicles are the use of unmanned rail vehicles to assist the communications in the fifth and sixth generation cellular networks. We will speak about the first category, how to use the unmanned rail vehicles as or the applications of unmanned rail vehicles as the use case of the fifth generation cellular networks. There are numerous apps of unmanned rail vehicles that can be used. We will consider the civil applications. The most common civil apps of unmanned rail vehicles are the surveillance applications. Other applications are applications of unmanned rail vehicles in agriculture, security apps, modern marketing, delivery for goods, rescue missions, and in remote sensing. Moreover, unmanned rail vehicles can be used in military apps, as presented in the slide. The second category for unmanned rail vehicles applications are the use of unmanned rail vehicles to assist the communication in 5G and 6G cellular networks. Unmanned rail vehicles can be used in two ways to assist the communication in fifth and sixth generation cellular networks. The first, we can use the unmanned aerial vehicles to assist the communications in dense deployment networks with a large number of devices. We can use the unmanned aerial vehicles to provide coverage for such devices, to provide energy resources, to provide computing resources. The most common example of this is the Internet of Things. We can use the unmanned aerial vehicles to provide computing resources, to provide storage and processing. We can use the unmanned aerial vehicle not only for Internet of Things networks or for certain parts of the Internet of Things, but also for the cellular networks in the large number of devices with dense deployment. The second subcategory is the use of unmanned vehicles to assist the ultra-low latency apps of 5th generation and moving to the 6th generation cellular networks. The most common example of such apps is the use of unmanned vehicles to assist augmented and virtual reality applications. These are the challenges of energy, then the security resource allocations. Key enabling technologies to overcome these challenges are the distributed edge computing, software-defined networks, and artificial intelligence. We consider the artificial intelligence in this presentation. We can use the artificial intelligence to empower the unmanned vehicles and overcome the challenges in many different ways. Design and development of the flight of unmanned vehicles. We can use artificial intelligence to make the real intelligence. We can use the artificial intelligence to assist the unmanned vehicles apps, and we can use the unmanned vehicles for resource allocations. That's all. Thank you.
Большое спасибо выступающим. Это очень интересные доклады, учитывая, что они носят в себе практический характер. С удовольствием разместим эти презентации для того, чтобы все участники смогли более детально изучить. И контакты коллег будут указаны также. Все смогут офлайн задать вопросы. Сейчас я попросил бы всех, кто может, включить камеры. И у нас запланировано фотографирование. Так, вижу, все появляются потихонечку. Вот, вижу даже Амар тоже попал в кадр и пропал, пропал. Амар, вы фон отключите, а то вы периодически пропадаете. Хорошо, нас секретариат сейчас сфотографирует. Я бы, наверное, хотел коротко подвести пока итог нашей сессии. Это получилась очень интересная и насыщенная информационная сессия. Мы хотели бы пригласить всех, кто принимал участие в этот раз в качестве слушателей, может быть, подумать над тем, чтобы подготовить доклады к следующим таким информационным сессиям, поделиться о своих наработках, поделиться своими планами о работе в области искусственного интеллекта, а также, учитывая информацию от Томаса, Фредерика, Рейнхарда, может быть, мы все подумали бы принять участие в том, чтобы сформулировать проблемы в области искусственного интеллекта, поучаствовать в программе совместно с ITU. Я хотел бы поблагодарить от лица организаторов сегодня всех участников за их выступления, всех, кто принимал участие в качестве слушателей. И хотел бы сориентировать вас о нашей дальнейшей работе. В 12:20 начинается собрание региональной группы регионального содружества в области связи по работе с Международным союзом электросвязи. Мы будем рассматривать вопросы подготовки к полномочной конференции, итоги проведения рабочих групп совета, подготовку к консультативной группе по стандартизации, подготовку к Всемирной конференции по стандартизации, по развитию. Поэтому те, кто должен принимать участие, я прошу вас остаться или подключиться. Так, мы фотографии сделали, да, Анастасия? Да, фотографии сделали. Я вижу довольные улыбающиеся лица. Вот. Большое спасибо. Тогда объявляется перерыв, да? Или, да, все говорят, что очень хотелось бы. Поэтому я еще раз хочу поблагодарить, передать привет всем, кто подключается издалека. И мы ждем вас в 12:20. Завтра мы начинаем форум 9 часов, также утром. Тоже не забудьте подключиться. Будем вас ждать. Всего доброго. Встретимся в 12:20. На кофе-брейк вот сюда. Здесь вот.